Hello, and welcome to Summarize Science. Today, we're looking at a fascinating paper that pushes the limits of how smart an AI can be, using a clever trick that doesn't involve expensive retraining. The researchers call it asymmetric verification, and it allows them to create supercharged, heavy versions of existing AI models. As you can see from these charts, their results are impressive, sometimes even beating the best proprietary models from big tech companies. So, how does it work? Normally, to make an AI smarter when it's solving a problem, you can do one of two things. You can either make it think longer on a single path, which is called sequential scaling, or you can make it brainstorm many different answers at once and pick the best one, which is parallel scaling. But there's a problem with just brainstorming more and more answers. This graph shows that while the AI gets better at finding the correct answer somewhere in its list of possibilities, it gets no better at actually identifying which one is correct. It's like finding a needle in a haystack, but you keep adding more hay and more needles. This brings us to the core idea of the paper: asymmetric verification. The concept is simple. Checking if an answer is right is often way easier than finding the answer in the first place. Think of solving a Sudoku versus just checking a finished one for errors. Table 1 here shows this perfectly. For the model GLM 4.5, it takes over 75 tool calls or steps to find an answer, but only 18 to verify one. So, the researchers decided to split the work. They use one AI as a search agent to generate potential answers. Then, they use a second, separate AI as a verifier agent, whose only job is to check those answers. This graph shows how much more efficient this two-step process is. Adding a verifier boosts accuracy far more for the same amount of computational cost compared to just making the searcher work harder. By applying this search then verify method, they created heavy versions of several open-source models. Table 2 shows the final results across several challenging benchmarks. Look at GLM 4.5 Heavy. It goes from 19% accuracy to 54% on the BrowseComp task, putting it on par with top systems like OpenAI Deep Research. Another model, Tongi Deep Research Heavy, achieves a staggering 69%, far surpassing everyone else. So, to recap the important points, instead of just using more computing power to make an AI search for answers, it's far more efficient to spend some of that power on a verifier. This asymmetric verification strategy allows open-source models to be upgraded into heavy variants that can compete with the world's best. This could be a game-changer for the future, leading to more powerful and accessible AI systems that don't require the colossal resources of giant tech companies to achieve state-of-the-art performance.